All right, everybody, welcome to the daily SAT live stream, the Gradeful daily live stream. Today is December 6th, the day before December 7th SAT. And this video, we are taking a break from the answer explanations we've been doing this past week, and we'll be focusing on key aspects for tomorrow's test. So if you're watching this live, great job. If you tune in later tonight, hopefully it's not in the wee hours, but even if it is, a lot of helpful tips here. So make sure you stay tuned, and any bit that helps will be good for tomorrow's test. So thanks for joining us. Alex, I'll let you take it away.
Okay, so today we're focusing on math only. The reading of the SAT is pretty predictable. You know what you're going to get. We've been talking about it at length. Writing on the SAT, same thing, same rules that keep occurring. Feel free to look at our recent videos to find out more information on that. But the area where the surprises lie on the SAT is in the math. There's no question about it. Little ideas are coming up that didn't show up on any previous tests. So tutors who are generally sort of looking at previous tests and just trying to prepare their students for what they know is on every SAT, kind of like you would do on reading and writing on English language. This is not working. There are just a few things. If we're focusing our energy on students today who are trying to get some of the highest scores. So if you're really making sure that, you don't want to miss a single thing, here are some of the miscellanea that you may not know that you need to be ready for tomorrow's SAT. So we're starting with the box and whisker chart. You need to be able to create one really smoothly. On one of the recent tests, there was a box and whisker involving some really involved information. So the quick explanation of box and whisker, everything you need to know, says that we need to find the median of the data. The median splits the groups into two separate groups. So you'll have the median of group 1 and the median of group 2, right? Now, so you have three medians. So between those three medians, you're going to have your box and your whisker. So by the way, what's the purpose of box and whisker? It's to kind of show you the way the data leans, because depending on the numbers, I might have like my box right here and then the whisker right here. So this is kind of telling me that the general data leans toward the left side of it all. And but within the center of it, it leans toward the right side of it all. So if you think of different applications in industry and so on, it might be helpful to kind of get that type of take on certain data. But it's really simple. And then one more thing before we get into using this as an example is, you're going to have your lowest value, your highest value, your first median, your third median, and then your actual median, which I guess we can call the second one, right? So you got, this is called quartile 1, quartile 2, and quartile 3, the three medians. And we'll sort of show that in more detail. The reason I'm getting into so much detail on that is that on one SAT, they asked for the distance between Q1 and Q3, a very fancy phrase called the interquartile range. So this is what, if you're one of those students who's really got a shot at a 1400, 1500, 1600 on tomorrow's test, this is what they're doing to really throw a wrench into what you're trying to do. They're kind of dropping in some of these obscure things. And on the test where box and whiskers came up, there were 2 questions involving the box and whisker. So your score could potentially drop down. If you're just a perfect mathematician who's just not really prepared for this topic, you could go all the way from 800 to like 760 just over the fact that you were surprised by this. So that's what we're here to do, is to kind of show you that. So let's go ahead and practice this on the data that we have right now. So we're going to get the median in general. Okay, so another thing is frequency charts just in general freak everyone out. When we're doing our tutoring on a daily basis, these are the questions that everyone's going to get wrong. So just keep that in mind, and you'll kind of get more used to it as you're seeing this. So if we're finding the median, as I'm counting in from here, I have 20 values. As we're counting in from here, we have 10 plus 16, so 26. So we've counted 26 numbers here, 20 numbers here. The reason why we're counting inward is to find the median, you got to find the middle number, right? So as I add 20 plus 24, I'll just cross that out. Now we're at 44 numbers, right? And then when we add 26 plus 35, we are at, let's say 26 plus 35, 61 numbers. All right. So, for the purpose of this discussion, I'm just going to go ahead and create, actually, I'll leave it like that. Okay. So for this particular group, the median has to be one of the numbers within this bar. because when we're looking for just where the middle number would lie, because you have 44 on the left and 61 on the right, I know that the actual middle number is somewhere right in here. So actually, for the purpose of this discussion, let's just go ahead and pretend instead of 0 to 9, 10 to 19, and so on, let's call all of these numbers sixes, all of these numbers 14s, 23s, 34s, 45s, 53s, and 62s. Just made up numbers just so that I can explain to you better how to create a box and whisker chart. And if this saves your life for tomorrow's test, please come on to one of our videos, leave a comment, let us know. We would love to find that out, because that's what I get a lot as a tutor. I find out that, you know, oh man, that last minute thing you told me, that was totally on the test. Awesome. Patrick, what's up?
Also, great point, just to mention it as well, if you're not in the 14 to 1600 range, and this seems a little bit higher level, refer back to our other videos. We have many other videos going over basic math concepts that you will need to know to go anywhere from 1000 to 1400. So if this seems a bit scary and you don't have much time left before the test, take a step back, try and watch it. If not, refer to our other videos. There's a lot of content out there that will help, again, get you from a 1000 up to 1400. In the meantime, as you said, Alex, if you're in the higher percentiles, you need to know this. If not, use your time wisely and check out our other math videos.
Awesome. So, okay, so I just created numbers because when you're dealing with something like the median, you can't have a range, you need the actual number. So right now the median will be the number 34. So all of the numbers, all of the 35 numbers in this red bar are all 34s. So we'll say the median is 34. Okay, so now how many numbers do we have all together in this set of data with the frequency that's being given? 5 plus 15 plus 24 plus 35, 16. I'm adding all the numbers of numbers, all the frequencies. So there's all together in here, there are 105 numbers to choose from. So we have 105. So when we remove that 34 from the middle, that leaves us 104. This was all on a real SAT, all of the same stuff. So we're not overdoing it here. But if I give you the number 34 in the middle, that means that we've got 52 numbers on this side and 52 numbers on that side, right? Okay, so 52 numbers on each side. So if I've got a set of data with 52 numbers here and 52 numbers here, for this set of data on the left, if I want the median, that means I need to count in the 26th number from the left or the 26th number from the right, because 52 divided by 2 is 26. So I need to know what's the 26th number in here. So if I count in from the left, I've got 5 plus 15 is 20, plus 24 is 44. So the 26th number is going to be from this data set, which we arbitrarily said was a 23, just for the purpose of this example. Same thing on the right-hand side. We've got 26 numbers here. Well, we got 52, which means that if I want the middle number, I need to count the 26th in from here or the 26th in from here. So obviously it's easier to go from the outside in. So as I count through here, I've covered 10 numbers, 6 plus 4, plus 16 more numbers. So actually literally 26. So the 26th number from the right is 45. And the next number down would be 34. So we picked the doozy with these numbers. So if you have an even set of numbers on a median and you need to know the median. Okay. Just thinking of like the simple way to explain this. Okay, so
if you
if
have
I
a set
have
of numbers and it's an even, if it's an even number, or if it's an even amount of numbers and you want the median, I think that's what you're trying to say. Or if
exactly.
you have a set of numbers, an odd number for the median. Yeah.
So if I have these 5 yellow numbers, it's easy to say the median is this red one in the middle because it's clearly in the middle. But if I have 6 yellow numbers, then, and that's an even set of numbers, the median needs to be the average of the 2 middle ones. So I need to add those 2 and divide by 2. So in this situation we're looking for the 26th number in from the right. That number is 45, and the 26th number from the middle this way is a 34. So the median right here is going to be the number we get by doing 45 plus 34 divided by 2. So let's just get that number. And that's going to be 39.5. And so all we need now for our box and whisker chart, is the lowest number, which is 6, the highest number, which is 62. And we just showed you how to create a box and whisker chart in a really complicated situation. The only thing left to know from things that are related to this on the SAT is the distance from here to here is the interquartile range. So if you're asked for that really obscure phrasing, the interquartile range is the distance from 39.5 to 23, which is 16.5. So the interquartile range is the number 16.5. So now just imagine if you hadn't watched this podcast and you see this on tomorrow's SAT, it doesn't matter how smart you are. It's background information. And that's what we're here to help you with. So let's go ahead and go on to one of the next topics that we might see, rational equations here. This is not a surprise. We see these on a lot of SATs, but a lot of students don't necessarily know the efficient way to do this. The idea is that we've got denominators. These denominators make everything complicated. If we didn't have x's on the bottom, it would be a ton easier. But x squared minus 25, by the way, factors to x plus 5, x minus 5. So in this situation, when you got denominators to get rid of, the easiest way to proceed, remember, we're not just here to get the right answer. We're here to get the answer easier so we can make it to the end, so we can have more emotional power left over. You multiply both sides by the denominators you don't want. So this green one is x plus 5, x minus 5. So when we distribute here, we'll have 3x squared because the green thing cancels against here. When you distribute in here, now the x plus 5's cancel, but the x minus 5 doesn't. So that gives us minus 4x, which is what was there before, times x minus 5, because like I said, the x plus 5's cancel. And on the right-hand side, the x minus 5's cancel, leaving you with 2x plus 5. So this is the setup you get when you do it sort of the easiest possible way. And then from here, it's a regular quadratic that you're solving. And for a quadratic, you get one side equal to 0. So negative x squared, taking away 2x from both sides, plus 18x minus 10 equals 0. And you want the x squared term to be a positive. So x squared minus 18x, rather, plus 10 equals 0. And just as a little bonus here, you want to know how to complete the square. Not everything is going to factor. So this doesn't factor nicely. So we can actually complete the square. So, this is a quick video. We're not going to cover every single little thing, but you'd want to complete the square here to get your answer. You'd be adding b over 2, and you'd to do the completing the square method. In the world of learning things on YouTube, just look up that word if you need more information. Patrick?
Yeah, and also just to mention, we covered that in one of our previous videos, so you don't have to look any further than the Gradeful page. There's a video there where we completed the square.
Okay,
so feel
awesome.
free to refer back to it.
Yeah, so completing the square, just doing it a little on the quick side, involves b over 2 squared. Remember, a quadratic's ax squared plus bx plus c, so the thing in front of the x is the b. So that's minus 18 divided by 2, you get negative 9. Square that, you get 81. So we're adding b over 2 squared to both sides because that's what you do in the method. So now we have x squared minus 18x plus 81. And the b over 2 is what it'll factor to. So that factors to x minus 9 squared equals 71. Square to both sides, x minus 9 equals plus or minus root 71. And the answer is 9 plus or minus root 71. On the SAT, you're more likely going to have something that factors here rather than completing the square. But just in case you don't know how to do it, make sure you know the ABC factoring method in case you need it. So for instance, if I had something like y equals 2x squared plus 5x minus 7, and this doesn't factor because I just made it up off the top of my head, but know how to factor something like that. When there's a number in the A spot, there's a process for that. And if you look it up, or if you look at one of our previous videos, you'll find out how to factor that. We're talking about all the ammunition you need to do well in an SAT. So moving on, here we've got a vertex. One thing that they've been killing people with on SATs are false x and y axes. So they're just waiting for you to just say that 70 is the y-intercept for this parabola, something like that. And so one very important formula that you don't want to go into an SAT without is the vertex formula of a parabola. Y equals a x minus h squared plus k. So they'll give you something like this and they'll ask you, which of the following looks like it could be the equation? Well, first of all, it's an upside down parabola. So we know that this number here has to be negative. That's one very important thing. The other thing is that the vertex appears to be, let's say, just generalizing it, 325/130, right? So then the h and the k in the vertex form are going to be 325 and 130 right there. Now that a in the front, all you need to be able to do to find out what a is take one of the points. Like in this case, we can say this point right here, 200 slash, comma 70 roughly. And when you plug that in, so y is 70, x is 200, everything else stays the same. This will allow you to solve for y. So between being aware of false x and y axis, knowing the vertex form of a parabola, and plugging in the point you have to find the a, you can get the equation. And also knowing that if it opens downward, it has a negative sign in the front, you can get the equation of the parabola. Patrick?
Just to clarify, so the false x and y axes, can you just explain it maybe, just in case someone's watching who doesn't understand exactly why the one you have pictured would be identified as false?
Well,
axes?
if I draw an actual xy axis, that means that this point right here is 0, 0, right? So then if we have like 200 around here and 40 around here, that means that, 200 comma 40, which let's say 200 comma 70 to keep
70.
it consistent with what we did before, is generally going to be the point that looks like the y-intercept here. So that point's actually going to be over here. So the parabola on an actual graph that has correct xy axes is going to look something more like that. It's not going to hit the axis where it appears to hit, because the true x and y axes are the areas where x is 0 and y is 0. So in this graph, it would be, not to scale, but it would be off this way somewhere.
So just make sure if you may get one with the correct, right? The correct axes with your 0, 0. Beware if you get one like this, keep that in mind.
All right, awesome. So moving right along now, Patrick, you have the roll, by the way?
We can go through this one and then we
Okay.
can wrap up after, if that's good with you. I'll let you.
Well, I'll probably knock out the rest of them.
Okay, perfect. So
okay.
I'll stay on with this one for you and then.
Yep, no worries. Okay, so this is another one. All of these are just things where, if you just coincidentally didn't know this already, you'll just be in a lot of trouble. So we're just here to kind of be the angel on your shoulder. And hopefully you'll be grateful for us and let us know how much we helped you if any of these do come up on an SAT and you wouldn't have known them otherwise. So what I'm talking about here is, if we think of this as almost a parent function, x squared plus 5x minus 36 equals 0, that would have factored two numbers that add to 5 and multiply to negative 36 are going to be x plus 9 and x minus 4. So if that's the case for, the regular quadratic version of this, then this one's going to factor to x squared plus 9 and x squared minus 4. And by the way, then you set both of them equal to 0. So just, look how hard this question would be without knowing this tip, right? So if the regular quadratic in this situation were x squared minus x minus 12, that's going to factor to x minus 4, x plus 3. If that's the case for a regular function, then this half-step quadratic, because it's got radicals in it, is going to factor to radical x minus 4, radical x plus 3. So super useful. If you end up with your back to the wall on this, there would just be no way to muscle your way through a question like this without knowing what's really going on. So, okay. So moving right along to our next one. All right, Patrick.
So very good there. Lots of good points. As I mentioned, if you're not in the 14 to 1600 range, refer back to all the other videos that we've made. Many of the previous videos cover basic math and then some reading, and there are a lot of English tips also. And I'll let you take it away from here.
Alrighty, Patrick. Have a good day today. We'll talk soon, brother. Alrighty. So here we've got two lines with infinite solutions. And what does infinite solutions mean here? Well, first of all, if they're lines, there's three ways that two lines can interact with one another. They can hit each other once, they can hit each other never, or they can hit each other always. Like in other words, if they actually are the same equation as one another, they'll always be in contact. So this is the idea of having one solution, zero solutions, and infinite solutions. So for this system of equations, we're being told that it has infinite solutions. So they're actually the same line as each other. That means that if they're both in y equals mx plus b, this 3a is equivalent to this 4. And this 2 is equivalent, this 2b is equivalent to the 5. So we can just solve for the variables by saying 3a equals 4 and find a that way. Or we could have said 2b equals 5 if we needed b, and b would be equal to 5 over 2. So that's the idea of the infinite solutions. Here, we're being told there are no solutions. So no solutions means that my two lines, if they went on infinitely, they'd never hit each other. And so what does that mean? That means they have different y-intercepts, so different b's, and they have the same slope, the same m's. So we can arrange these both into y equals mx plus b and just go ahead and demonstrate that. So for the first one, I can take away ax from both sides. Divide by -4. And okay, doing it for the other one now, you got -2y, take away 8x from both sides. Divide by -2. And so now we've got the equations of the two lines. Now we said for there to be no solutions, the slopes have to be the same. So a over 4 has to be equal to 4. A over 4 equals 4, which means that a is 16. And for the y-intercepts to be different, I simply know that -3 over 2 times c cannot be equal to -4. So these two guys, which would be in the position of being the y-intercept, they cannot be equal to each other. So I'm just going to go ahead and solve it as if it were equal, and then that'll tell us what number we're not able to have. So I'm going to multiply both sides here by -2 over 3. And we get c equals 8 over 3. So remember, we were judging what was not going to be allowed. So this cannot be the case. So now we know c cannot equal 8 over 3. So c can be any number except what? 8 over 3. And what's the value of a? 16. So going to the next concept, this was a surprise on one of the recent SATs that I viewed. Just amazing to know that they're asking this. It's really easy if you're prepared for it, really tough if you're not prepared for it. So we know it's a parabola. A parabola is going to be in the format of y equals ax squared plus bx plus c. And if it passes through the 5, 0, that's our easiest point. So if you plug in 0 for y and 5 for x, then you get 0 equals 25a plus 5b plus c. Then we can plug in the next point, 6 and 4. 4 equals a times 6 squared plus b times 6 plus c. So simplifying through, 4 equals 36a plus 6b plus c. And then for the last one, we've got 5 equals a times 10 squared plus b times 10 plus c. So simplifying through, 100a plus 10b plus c. Now the example I saw in an actual SAT was a tiny bit on the easier side. But we can still do this. We have 3 equations and 3 variables, so we can take little steps to make sure that they cancel out. Like for instance, I can multiply this equation by -1. -4 equals -36a minus 6b minus c, and then bring that right over here. -4, -36a, -6b minus c. And we can just go ahead and add straight down. 1 equals 64a plus 4b, and we've gotten rid of one variable. Now we can do the same thing, let's say with, let's take this equation and bring it down here now. -4 equals -36a minus 6b minus c. -4 equals -11a minus b, and the c's cancel out. So right now, we have a nice system of equation with 2 equations and 2 variables. So it'll solve nice and easily. So I can multiply this one maybe by 4 to get the b's to cancel out. So -16 equals -44a minus 4b. Plug that back into the other one. -16 equals -44a minus 4b. And -15 equals 20a. And we finally have one of the answers. A equals 15 divided by 20, which is -4/3. So knowing that a is -4/3, you can plug that back into either of your equations that have 2 variables. Let's go ahead and zoom out a little bit here. Create a little more space on my page. Now, the similar question to this on the SAT actually had this number right here being 0 and this number right here being a number. So that made it so much easier. So this process of solving for 3 variables, you never have to do because the x gets zeroed out in one of the situations. So this example is a lot harder. So as long as you know the idea of plugging in the different combinations of x's and y's, you'll notice that it'll solve much easier. This is kind of extra advanced for the math Olympians out there. So we've got 1 equals 64. Now I'm just plugging in the -4/3 that we got. 1 equals 64 times -4/3, which is the value of a, plus 4b. And we can go ahead and solve that out. 64 times -4/3 is -85.3. 1 equals -85 plus 4b. So adding that to both sides, here you'll have 86 1/3 equals 4b, and you can divide by 4. And you'll get 21.583 repeated. So getting some crazy numbers here, but they are numbers nonetheless. So now we can plug back into any of the original equations, the a that we know and the b that we know. 25a plus 5b plus c. So as complicated as that looks, we have only one variable to solve for, so it's solvable. So I've got 0 equals 74.583 repeated plus c. So c comes out to the negative of that number. So like I said, know that you need to plug in these 3 numbers into the x and y pairing. So here we had one x and y pairing. Here we had another. Here we had another x and y pairing. And here we had a third x and y pairing. And know that that'll set you up to be able to solve. So that highlighting was done a little fast, but I think you get the idea. So let's go ahead and go to one of the next situations that you're likely to see on the SAT that perhaps you won't be ready for without this help that we're offering to you. Margin of error. So what does it mean? How can we apply the fact that the margin of error is plus or minus 1.5%? And of course, when you do this video or any similar video, you can always pause when you see the question, try it on your own, and then compare your answer to the answer in the video. So we have 25,000 marbles, and the estimate is that 7% of them are red. So what's 7% of 25,000? It's 1,750. Okay, now the margin of error is plus or minus 1%. So what if it were plus 1.5%? That would be 8.5%, 0.085. Or if it were minus 1.5%, it would be 5.5%, 0.055. So we could have gotten the numbers that were 5.5% of 25,000. So like, in other words, we have the 7%, but that 7%, can be taken down by 1.5%, and it can be taken up by 1.5%, because that's the margin of error. It says we're not sure that it's exactly 7%. It could be off by up to 1.5%. So what's 5.5% of 25,000? That's 25,000 times 0.055, which is 1,375. And that'll be our answer, because that's the smallest possible number of red marbles. But just for a deeper understanding, what's 8.5% of 25,000? It's 2,125. So the estimate says that there will be 1,750 marbles, but because of the margin of error, it could be as low as 1,375 or as high as 2,125. And so the answer says, what's the smallest possible number of red marbles? And the answer is the smallest number within that range, 1,375. So that's a little understanding of margin of error for us for our upcoming SAT. And this will be our last question of this session, would be arcs. So AB is congruent to AC. Okay, great. AB congruent to AC. That creates an isosceles triangle, and an isosceles triangle is going to have two congruent base angles. So 100 plus each of those has to equal 180, and the two red angles are equal, so they both need to be 40. What's the degree measure of minor arc AB? So the thing that you may not know is that if I have a central angle, let's say this is a 45-degree angle, there's a 1-to-1 ratio for central angles. This will be a 45-degree arc. But if I have an inscribed angle, so I have the same 45-degree arc right here, there will be a 2-to-1 ratio. So this angle will now be 22.5 degrees. It'll be half. So there's a 2-to-1 or a 1-to-2 ratio for inscribed angles. So what we're saying is that if we're being asked for the degree measure of minor arc AB, that's going to be the 2-to-1 ratio if the angle that corresponds to that, which is this angle right here, or I'll do it in a different color. If that angle right there is 40, then the degree measure of minor arc AB is going to be 80. And so that would be the answer to that question. It's going to be twice of the angle that it intercepts. So we really hope this helps you, and it would make a world of difference to us if you let us know that any of these tips helped you on tomorrow's big SAT. Good luck, and thanks for listening.